Welcome to The Explainer. Today, we're jumping straight into a source text that makes a pretty massive claim that a simple, natural chemical compound heavily researched back in the 1960s is actually a suppressed medical miracle. The text we're analyzing goes deep, and I mean really deep, into a substance known as DMSO, or dimethyl sulfoxide. And according to our source, this isn't just some fringe alternative remedy. They argue it's a foundational biological protector. So let's dive into exactly what they mean by that.
Right off the bat, our author hits us with a wild what if. What if one forgotten chemical could literally protect the human brain from fatal injury? We are going to explore the author's boldest claim today, that a safe, near-universal cellular protector was essentially buried by the modern medical establishment. And honestly, whether you consider yourself a huge skeptic or a firm believer in holistic medicine, the historical and biological data presented in this text is just absolutely captivating.
Section 1. The Forgotten Medical Miracle. Okay, to really understand where this author is coming from, the source requires us to look at a huge philosophical divide in medicine. On one side, you have reductionist medicine. This is all about treating downstream symptoms, finding a very specific, patentable cause for an illness and managing it. Contrast that with holistic medicine, which zooms out to look at systemic processes, arguing that a lot of specific diseases are really just different symptoms of one overarching failure in the body's environment. According to our source, DMSO was rejected by the mainstream precisely because it fits squarely into that holistic model. It acts as a broad, systemic protector, not a targeted, patentable drug.
This philosophical divide directly informs the author's theory of chronic disease. The source maps out how illnesses become permanent, kind of like a domino effect. First, the system experiences a shock. Second, the affected area literally goes into a shutdown mode, just to survive. Third, your body's natural healing capacity fails to reboot the system. And finally, all the connected systems start going completely haywire. Here's the kicker. The author claims that DMSO physically intervenes in this exact cascade, actively waking up those dormant cells and reversing the shutdown.
Section 2. The biology of DMSO.
Now let's talk about something called blood sludging. Gross name, I know, but the concept is fascinating. The author draws on historical biophysics to explain that a lot of diseases actually stem from our blood cells losing their electrical charge and just clumping together. This sludge ends up blocking microcirculation, starving your tissues of oxygen. The text posits that DMSO steps in as a gel stabilizing agent within our fluids, so it doesn't thin the blood like your standard anticoagulant would. Instead, it naturally spaces the cells out, completely counteracting this lethal clumping and restoring flow right down to the microscopic vessels.
Which brings us to DMSO's actual physical properties. And honestly, the source makes it sound almost like a biological superhero. It's a near-universal solvent, but crucially, it can cross biological membranes without doing any damage. The author notes it can even effortlessly cross the blood-brain barrier. Because it carries a completely neutral charge and acts as a potent antioxidant, it can supposedly deliver therapies deep into tissues while protecting cells from stressors that would otherwise be completely lethal. We're talking freezing temperatures, severe burns, or total oxygen starvation.
Section 3. Rescuing the brain.
The stakes here are absolutely massive. And this matters because vascular diseases are so painfully common. This source reminds us that 800,000 strokes occur each year in the U.S. alone. It's a leading cause of death and permanent disability that touches millions of families. And yet, the text argues that our standard medical treatments for stroke are shockingly limited and incredibly risky.
To understand why it's so risky, we have to look at the difference between the two main types of strokes. An ischemic stroke is caused by a clot, while the hemorrhagic stroke is caused by a ruptured, bleeding vessel. The author points out a terrifying flaw in emergency medicine. The standard clot-busting drugs used for ischemic strokes can be instantly fatal if the patient is actually having a hemorrhagic stroke. Because of this, doctors have to delay treatment until they can get a CT scan. But, according to the text, DMSO safely and miraculously treats both types of strokes by protecting the brain tissue itself, meaning, theoretically, you could give it right away in the ambulance.
You know the old saying, time is brain? Standard clot-busting treatments have this incredibly strict 3 to 4.5 hour window, and they carry severe bleeding risks. But the source points to a fascinating yet completely forgotten 2002 clinical trial. In this trial, researchers claimed that intravenous DMSO benefited stroke patients even when it was given up to an astonishing 12 hours after the symptoms started. They were supposedly rescuing brain tissue long after standard medicine would have considered it completely dead.
And the author doesn't just stick to clinical trials. They back this up with some pretty jaw-dropping human stories. Take the story of a Los Angeles schoolteacher who suffered a major stroke. According to the source, she was given immediate aggressive DMSO treatment by a family friend who happened to be a surgeon, completely bypassing the standard hospital route. As the text describes it, she made a rapid, full recovery, going right back to teach after the holidays as if absolutely nothing had happened. It's an extraordinary claim of cellular rescue.
Section 4. Reversing spinal cord injuries. The text highlights some highly dramatic testimony from early researchers, particularly Dr. Stanley Jacob, who's basically known as the pioneer of medical DMSO. He testified to seeing total recovery in patients with immediate, complete quadriplegia as long as intravenous DMSO was given within an hour of the injury. The source argues a really interesting point here, that paralysis isn't always immediate nerve death. Instead, it's often the result of post-injury swelling and blood loss that slowly kills the nerves over several hours.
So how exactly is it supposed to achieve this? Well, according to our source, DMSO acts like a Swiss Army knife for your nervous tissue. It rapidly lowers intracranial pressure by drawing excess fluid out of the brain and spinal cord, and it supposedly does this without causing any rebound swelling. At the exact same time, it lowers inflammatory cytokines, scavenges tissue-destroying free radicals, and actively ramps up blood flow to the starving nerves. The text claims this multi-pronged approach effectively halts the cellular death cascade in its tracks.
Section 5. Repairing proteins in cognition.
Now, the text introduces us to a really cool biological concept, the chemical chaperone. Think of these as tiny molecular babysitters. They're small molecules that basically ensure proteins fold into their correct shape. And misfolded proteins are actually the root cause of a lot of devastating, supposedly incurable diseases. The source describes DMSO as a powerful chemical chaperone that stabilizes these proteins, or, if they're too far gone, helps dissolve and flush out toxic protein clumps, like the amyloid plaques you see in several severe cognitive conditions.
To ground these cognitive claims, the author shares the story of a little girl named Melody Clark. According to the text, Melody was an infant with Down syndrome who was exhibiting classic, very severe developmental delays. The source claims that after starting a protocol that involved DMSO and amino acids, Melody progressed at an astonishing rate. By age 8, the text asserts she was reading, running, and functioning at a near-normal level in a mainstream classroom. The author attributes this directly to DMSO, literally awakening dormant neural pathways.
Building on stories like Melody's, the text cites dozens of international studies that argue for some incredibly broad cognitive applications. The source claims DMSO can dissolve toxic amyloid aggregates all throughout the body. It's also been studied in lab settings for genetic disorders like Niemann-Pick disease to help improve cellular transport, and it's been used in specialized protocols to treat severe developmental delays. The author is really painting a picture of a substance that fundamentally alters how our cells handle damage and genetic errors.
Okay, so this naturally leads to the elephant in the room and the author's most pointed question. If these claims of cellular rescue, paralysis reversal, and protein repair are supported by decades of animal data and human anecdotes, why on earth isn't this in every hospital? The source firmly alleges that an unconscionable FDA embargo in the 1960s buried this vital research. According to the text, because DMSO is a natural, totally unpatentable byproduct of the paper industry, the paper industry of all things, the pharmaceutical establishment viewed it as a huge financial threat and waged a multi-decade war to keep it completely out of mainstream medicine.
So, we're left to weigh this pretty extraordinary narrative. Is DMSO truly a suppressed medical miracle capable of stopping strokes and reversing paralysis? Or is it simply a fascinating footnote in the history of holistic biophysics? Honestly, regardless of where you stand on the medical politics of it all, the science and history presented in this text leave us with a profound question. What other forgotten treatments might be hiding just beneath the surface of modern medicine? Thank you so much for joining me on this deep dive. Let this explainer spark your curiosity to always keep questioning and always keep learning. See you next time.